In today's lesson, we'll be learning about common factoring. In a previous lesson, we learned that you can go from this expression to this expression using expanding. And expanding uses the distributive property. And the distributive property uses the product rule, where coefficients are multiplied, bases stay the same, and exponents are added. We also learned that you can go from this expression back to this expression using factoring. Factoring uses the quotient rule, where coefficients are divided, bases stay the same, and exponents are subtracted. Basically, expanding and factoring are opposite processes. Expanding goes one way, while factoring goes the other way. In our first example, we want to factor the expression 12x to the power of 2 subtract 18x. The first step of factoring is to look at the greatest common factor of the coefficients. The coefficient of this term is 12, while the coefficient of this term is negative 18. I now want you to think of the largest number that can divide evenly into 12 and 18. The largest number that can do that is 6. So 6 would be the greatest common factor of these coefficients. The next step is to look for a common variable with the lowest exponent. Take a look at these two terms. They both have a variable of x in common. One of these has an exponent of 2, while the other has no exponent. But if it has no exponent, that just means there's a hidden 1. So the common variable here would be the variable of x, and the lowest exponent that you can see is actually an exponent of 1. Finding the combined common factor is pretty straightforward. You're basically going to take what you have in this box and what you have in this box and combine them. Therefore, it's going to be 6x to the power of 1. We're going to take this combined common factor and place it over here. And the original expression is going to go in brackets, unchanged. I'm now going to divide everything inside the brackets by the combined common factor, which was 6x to the power of 1. The 6x to the power of 1 in front of the brackets is going to stay exactly the same. At this point, you want to use the quotient rule. So over here, we want to take a look at the coefficients. That's 12, and this is 6. You want to divide coefficients. So 12 divided by 6 is going to give you 2. Next, you want to take a look at the bases. This has a base of x, and this has a base of x as well. Bases stay the same, so that's going to remain x. And last, you want to take a look at exponents. There's an exponent of 2 here and an exponent of 1. You want to subtract exponents. So 2 subtract 1 is going to give you 1. We're going to repeat this process all over again. So the coefficient here is negative 18, and the coefficient here is positive 6. You want to divide coefficients. So negative 18 divided by positive 6 is going to give you negative 3, since a negative divided by a positive gives you a negative. Next, you want to take a look at the bases. The base over here is x, and the base over here is x as well. Bases stay the same, so that's going to remain x. And last, you want to take a look at the exponents. There's an exponent of 1 here, and there's an exponent of 1 here as well. You want to subtract exponents. Therefore, 1 subtract 1 is going to give you 0. At this point, we'll want to clean this expression up. Remember, 1s are generally not written in as exponents. So I'm going to erase this exponent of 1 over here. I'm going to erase this exponent of 1 over here as well. Now, we haven't really learned this before, but anything to the power of 0 actually becomes 1, which basically means it cancels out. So this x to the power of 0 can be actually erased. Now, if you really wanted to check your work, you could use the distributive property and work backwards to get your original expression. And if you do, that means you've done this correctly. In our second example, we want to factor the expression 25x to the power of 3 plus 10x to the power of 2 plus 5x. The first step of factoring is to find the greatest common factor of the coefficients. The coefficient here is 25, the coefficient here is 10, and the coefficient here is 5. I want you to think of the largest number that can divide evenly into 25, 10, and 5. The largest number that can do that is going to be 5. Therefore, 5 is the greatest common factor of 25, 10, and 5. The next step of factoring is to find the common variable with the lowest exponent. Take a look at these three terms. They all have a variable of x in common. This term has an exponent of 3, this term has an exponent of 2, and this term does not have any exponent, which means there just is a hidden 1 above the x. So the common variable here is x, and the lowest exponent that we can see is 1. Finding the combined common factor is pretty straightforward. All you do is you combine this box with this box, and you get 5x to the power of 1. Therefore, that is the combined common factor. We're going to take that combined common factor and place it over here. The original expression is going to remain, but in brackets, unchanged. Next, you want to divide everything inside those brackets by the combined common factor, which was 5x to the power of 1. The 5x to the power of 1 in front of the brackets is going to stay exactly the same. At this point, you want to use the quotient rule. So we're going to take a look at the coefficients here, 25 and 5. You want to divide coefficients. So 25 divided by 5 is going to give you 5. Next, you want to take a look at the bases. The base is x over here and the base is x over here. Bases stay the same, so this is going to remain x. And last, you want to take a look at exponents. The exponent here is 3 and the exponent here is 1. You want to subtract exponents. So 3 subtract 1 is going to be 2. We're going to repeat the entire process again. We're going to divide coefficients. So 10 divided by 5 is going to give you 2, but since that's positive, you need to add a positive sign. And bases over here are x, bases stay the same, so that's going to remain x. And then we want to take a look at exponents. Exponents are going to be subtracted. So 2 subtract 1 is going to give you 1. Again, we're going to repeat this process once more. Coefficients get divided. So 5 divided by 5 will give you 1. And we want to add a positive sign in front of it. And bases are going to stay the same. So that's going to remain x. And last, you want to subtract exponents. So 1 subtract 1 is going to give you 0. We'll want to clean this up. Remember, exponents of 1s do not need to be written in, so we can erase them. And anything to the power of 0 becomes 1, which means it basically cancels out. So this x to the power of 0 can be erased. If you really wanted to double check your answer, you could use the distributive property to work backwards. And if you got your original expression, that means you have factored correctly.